not only to set out telescopes, but to experience space directly. Direct human experience of what it's like to live outside of the Earth's atmosphere. Here's some photographs of some of the earlier, no, that's not the case. What's wrong with this picture? Yeah, that's not good. Matter of fact, if you're in that spacesuit, you're in big trouble. Matter of fact, there's nobody in that spacesuit. I think, if I remember right, this is a photograph taken from one of the cosmonaut. The space station and cosmonaut was there, and they had this old spacesuit, and they just dumped it out in space. They got a photograph of it floating off. But yeah, that would not be good. You need some kind of propulsion system or a tether or something to pull you back in. Houston, we have a problem. This is kind of neat. It's like a lazy boy recliner in space. It's like a chair you sit in and drive around in space. Wouldn't that be cool? Yeah. You know, if I could do something, you say, okay, you get to do one thing. That would be pretty cool, to be like above the earth in your own easy boy recliner moving around. And just a thought. Of course, you're afraid of heights. Probably not a good thing. You can see the photographs they take in space. You can sense it's just very sharp because there's nothing to get in the way, because when you get out in space, it's just nothing. There's no molecule. I think they estimate there's like 1 atom per cubic meter or something. It's essentially an absolute vacuum. So tell me about space. What's it like?
Huge.
Yes, it's very huge when you're out there. It's like a giant void, but what are some characteristics of space?
Very frigid.
That's right. What causes temperature are the vibrations of atoms. Do you know that? If you ever, what is heat? It's vibration of atoms. Faster they vibrate, the hotter it is. Cooler they are, the slower they vibrate. There's absolute zero. That's where atoms stop vibrating completely. So heat is simply the vibration of atoms. So guess what? When you don't have atoms, there's no heat. And so space is extremely cold. It's pretty near absolute zero, hundreds and hundreds of degrees below zero.
So what makes up the nothingness of space?
Nothingness is not a something.
Right.
It's just nothing. No, you laugh at that, but the theologians came up with this concept of ex nihilo from the Hebrew word bara. Because when you see bara in Hebrew, God doesn't make something out of something else. So it created this idea that theologians called ex nihilo, which means out of nothing. And so other theologians were talking about nothingness as something out which God made things. So they had to say that God created without using pre-existing materials. So they just have to explain it, that nothing really is nothing. It's just space. And of course now they say that space is expanding. So how can nothing be expanding? And what is it expanding into? Scratch your head on that one. I don't know. Habitum Dei, I guess.
Come to that conclusion.
Oh, the space is expanding? Wow. I'm not sure I can answer that. See, the problem is some of these questions you have to have a physicist in the room, which I'm not, to answer. I'll give my best shot at it, because that's an important question. Whenever they developed the first Hubble, the Hubble scope was named after an astronomer called, I think his name Edwin Hubble. And Hubble began to look at distant galaxies, and what he noticed when he began to analyze the light coming from distant galaxies is that all the light was redshifted. In other words, when you look at light coming from stars, they have a certain characteristic to them in terms of the different wavelengths of light. But when you look at these distant galaxies, they didn't fit that mold. They were actually redshifted. And the further the galaxies were away from the Earth, the more red-shifted they were. So the question becomes, what shifts them to light, instead of normal mixture of light, what shifts everything to the red end of the spectrum? And his answer was, because they're moving away. It's you can explain it with the Doppler effect. He believed it was a Doppler effect, but applied to light. Doppler effect relates to sound. So here we go. I'm going to try to explain the Doppler effect. Sound is pressure waves in the air. This room is full of a substance called air. And as I make a sound, it's creating pressure waves that move through this room. And you're capturing, we talked about that before, and interpreting that as words or whatever. But there are pressure waves, and depending upon how that source of that sound is moving relative to you, the hearer, will determine the frequency of that sound. If the sound source is moving towards you, it compresses the sound waves. It compresses them, and so that makes them higher frequency. Just like if you have a wave or a slinky, you push it together, it bows up. So it gets a higher frequency if it's being compressed. But then as the sound source is moving away from you, hang on, I know this is tough, but you can just concentrate, you'll get it. As the sound source is moving away, it actually stretches out that sound wave, which makes it lower frequency. You see? And so whenever a sound source is moving towards you, the frequency is consistently getting higher. Then when the sound source passes you and moves away from you, the sound source is increasingly getting further away and longer wavelengths. It's stretching it out. And we hear that as pitch. So I can do it for you. Do the Doppler effect. And you could probably even hear the sound source coming and going away. If you listen carefully, you can hear it getting higher. And it goes lower. That's just part of living in the world, right? We all know that. If you've been to the NASCAR, it's or the train, is moving slower. Well, Hubble believed that light does that too, because it's a wave. So if there's a light source moving toward us, it's compressing, which means it's getting shorter wavelength, which moves it toward the blue end of the spectrum. It gets bluer. Light gets bluer if it's moving toward you. If light is moving away from you, it's stretched. Therefore, it's longer wavelength. Therefore, it looks red. Blue light's coming toward you. Red light is moving away from you. So now he applies that to the galaxies. They're red shifted. So what are they doing? All the galaxies, every galaxy is red shifted relative to the Earth, so they are all moving away from the Earth. And they're all moving away from Earth depending on how far they are from the Earth. Moving faster the further they are away from the Earth. Slower the closer they are to the Earth. And so first they believed that that was caused by the Big Bang, and that there was a big explosion. It's just pushing everything out. The problem with that is what? I know this is a hard thing to dig out. See if you can do it though. If there was a Big Bang and everything exploded and everything's moving outward from that Big Bang, yet everything is redshifted relative to us, that creates a dilemma. The problem is if everything's moving away from us, that makes us really special, doesn't it? That means that we're right in the center. But they don't want to handle that because that again says that we're special somehow. And so they come up with a new theory, and that is that, and here, this is the answer to your question, went the long way around. But either Earth is very special and that we were right at the center where it all happened if there was a Big Bang, or what they believe is that it wasn't that stars are moving through space, but that the stars are moving with space. That space itself is expanding. And so the Big Bang wasn't an explosion. And they never really believed it was an explosion anyway. They believe it's an expansion. So space is expanding. And as the space expands, it carries everything with it. So imagine that I had a balloon and I took a magic marker and I put black dots all over the balloon. All right? And then I blew it up. Then imagine you're standing on one of those black dots. It doesn't matter which black dot you're standing on, right? It will look like every other dot is moving away from you because the whole thing is expanding, see? That's how they view the universe. So the universe is actually expanding, space itself expanding, and that helps them explain that why everything is redshifted. And they believe, even though they can't do that, if they went to another galaxy and they looked, all the galaxies would be moving away from it too. Everything's moving away from everything else because the whole universe is expanding. So there you go, space is expanding. And it may be true, may not be true, but that's what they believe. And it's fascinating when you understand that concept, that space is expanding because in the Old Testament, several places it says that God has, what's the phrase? Hang on, it's in my head somewhere. Stretched out. That's the way it's translated, stretched out. God has stretched out the heavens like a curtain. Isn't that amazing? I don't know if that's true or not, but if it is true, that the universe is expanding, wow. Because there it is in the Old Testament. It could be the Old Testament writers just trying to say that when you see the night sky open up at night, it's God doing it. Or it could be, if the physicists are right, the whole universe is expanding. And so instead of the black dots being on a balloon, imagine the black dots are on a curtain, a tent curtain, and you're pulling it open.
So what is space expanding into?
Nobody knows. That's the big question. What is space like? It's very cold. Space is very, very cold. It's also very empty. All right? It's also, because it's so empty, there's no pressure out in space. It's a vacuum, essentially. So maybe this is a better way to answer. What would happen if I took one of you up in a spaceship and threw you out without a spacesuit? How long would you survive in open space without a spacesuit?
At least an hour.
If you've seen Hitchhiker's Guide to the Galaxy, I think you have like 36 minutes or something, which is bizarre. You know, Hitchhiker's Guide to the Galaxy is not true science. What's that?
Would you die instantly?
Probably pretty close to instantly. How would you die if you were thrown out into space without a spacesuit?
Explode. Freeze to death.
You'd probably turn to ice about the time you're exploding, because your body has to maintain a certain pressure. If space is an absolute vacuum, then you're going to blow up like a balloon. There's actually a scene, was it Mission to Mars? There's one of those space movies, Red Planet or Mission to Mars, one of those two, where there's a guy out in space and he gets a crack in his spacesuit. And it shows his face just kind of blow up like a balloon. As it blows up, it turns to ice. And I was thinking when I saw that, yeah, that's the way I always envisioned it. How you would die in space is your body would blow up like a balloon because the pressure, it's just no pressure. So you would blow up because there's pressure inside your body, and you'd turn to ice at the same time, probably crack. Not a very pleasant thought. There's also no gravity in space, so you would float. There's nothing to pull you down. It's a gravity-free environment.